In a previous video I showed how to make a GUI for the Arduino with Java, and in that video I showed how to read the value of a potentiometer that is hooked up to the Arduino and then have that value affect a slider on a graphical interface, a GUI, on the computer. And that was a neat little project, and it was very minimalist, but of course that didn't really have a whole lot of practical use. In this video I'm going to show how to do some data logging. I'm going to show how to take a sensor, record its values over time, and graph that. So here I have an Arduino, and what I have attached to it is a resistor and a cadmium sulfide cell. What it is it's a light sensor. So the cadmium sulfide cell, this little guy right here, is essentially a resistor, and its resistance will change depending on how much light it sees. When it's really dark, it'll have a very high resistance, in this case about 50 k ohms, and when it's receiving a whole lot of light, it'll be just a few hundred ohms. So I have the cadmium sulfide cell, and then I have a resistor, and the two of them form a voltage divider. So one end of the cadmium sulfide cell goes to ground, the other end goes to analog pin A0, and I also have from that analog pin a resistor which then goes to the 5-volt rail. You're probably curious to see what the end result was, and let's take a look at that. I stuck my Arduino in my windowsill, right there. Left it there for about 10 hours, or no, about 20 hours, just under a day. And let's see what we got. So we can see that we have about 20 hours of recorded data. I put the Arduino on my windowsill at around midnight, which is why there is very little going on for quite a while. You can then see sunrise, and by now the sun has begun to set at about 6:30 p.m. So let's take a look at how I got this working, and this video is going to be a little bit longer than some of my other ones, but that's because I wanted to thoroughly explain what I'm doing every step of the way so you can follow along and actually know what you're doing. There's a link to the source code down below in the description, so if you want you can just use that, or you can skim through the video, or if you are curious about all the details then watch it all the way through. Let's start up the Arduino IDE. And I'm going to use the same example as before. If you go to File, Examples, Basics, Analog Read Serial, we have a very simple sketch that configures the serial port, enters a loop where it will read from analog pin A0, output that to the serial port, and then loop again infinitely. By default it's going to repeat that every millisecond, or 1,000 times per second. And that's a lot faster than I need for this particular application, because I want to do long-term data logging. I only really want an update once per second, and even that might be overkill, but we'll stick with that. I'm going to change delay from 1 to 1,000. So if I zoom in, you can see I have delay at 1,000. If I then click the upload button, it will compile and upload it to the Arduino. And if I click on the serial monitor button, we get a console. As you can see, it is showing the values. So here I have the Arduino, and so I get this all in frame. There we go. Okay, so here I have the Arduino. If I put my finger over the cadmium sulfide cell to block out all of the light, you can see the ADC reading, which is effectively the voltage reading, goes much higher. It's about 825. If I take my finger back off, it goes back toward around 450, which is reflecting the ambient room lighting. If I take a flashlight and shine it at the sensor, the values drop down toward about 100. So that's kind of how this particular sensor works. It's very simple, very low cost, very easy to work with. So that's really all we need to do with the Arduino. The majority of the work is going to be in Java. And like in the earlier video, I'm going to show how to do everything. So even if you didn't see the earlier video, you can follow along. We're going to start by downloading a JDK, which is a Java Development Kit. That is what you need if you want to write programs in Java. So if you type in JDK, you'll get a link to Oracle's website. Click on the download button next to JDK. Click on Accept License, and then download the version for your operating system. While that downloads, I'll also download a copy of Eclipse, which is the Java IDE that I will be using. Search for Eclipse. Click Download. Eclipse IDE for Java developers is the one you want. Click the download link again, and click on the link for the local mirror. And so now that's downloading too. We also need two Java libraries. The serial port library is JSerialCom. Click on the link. There's 3 download links up here. You want the jar, so click on the jar. And Chrome is warning me that this can harm the computer. It's warning me because a jar is a Java program, so obviously you don't want to download a jar from an unreliable source. But this is going to be fine, so go ahead and click Keep. The other library is for the charts, and it's called JFreeChart. Click the download link. Click the download link again. Go to JFreeChart. Pick the latest version and download the file. Alright, so those are the 4 items that we needed, and we can go ahead and install the software. So we're done with Chrome. I'm going to close out of that. Or we're almost done. Okay, there we go. Download finished. Close out of Chrome. We'll go ahead and install the JDK first. And yes, we do want to run it. Click Next. Next. Click Next. And click Close. Alright, we're done with the JDK. We can delete that file for now. Next we have Eclipse. It comes in a zip file, a compressed folder, and there is no installation. You just copy that folder to wherever you want. I'm going to put it on the desktop. Alright, we can now close the zip file. We can go ahead and delete the zip file. And then our Eclipse folder, just move it up there. Inside that folder we have the Eclipse program and a bunch of other stuff. Let's put a link to the Eclipse program on the desktop. So if you right click, send to desktop. ahead and move that up here, and I'll rename it just to get shorter. Let's open up Eclipse for the first time. First time you open it, it will ask you where you want to put the workspace. The workspace is where all of your Java programs get stored. You can put it wherever you want. The default is fine, but I have a habit of putting it on the desktop, so I'm going to go ahead and do that. Go to Browse, Desktop, and I'm going to put it in a folder called Eclipse Workspace. And I'm going to check the box to use it as my default. Alright, so the first time you open Eclipse, you get this welcome screen. We can close the tab by clicking the X. And so that's what we're going to be doing most of our work in. Now that we have our Eclipse workspace folder, we can go ahead and copy our libraries into it. You can leave the libraries on the desktop, but I have a habit of putting them into the workspace folder because it's just a logical place to put them. If you're going to use them with multiple programs, might as well keep it in the workspace. So we have the JSerialCom file. We'll go ahead and put that in the workspace. And then we have a zip file for JFreeChart. If you open that, open its folder. And I believe, yeah, so if you go into the lib folder, we have a whole bunch of jar files. We only need 2 of them. Let's copy over jcommon, and let's copy over JFreeChart. The other ones we don't need right now. Close out of that. We can delete the JFreeChart zip file. Alright, so in our workspace folder, we have the JSerialCom library, the jcommon library, and the JFreeChart library. Those are the 3 libraries we're going to be using today. So in Eclipse, we will create a new project. Go to File, New, Java Project. Over here we need to give it a project name. I'm going to go ahead and call it Sensor Graph. All of the default settings are fine. Go ahead and click Finish. So we have a folder here. If we double click it, we have a source folder and a system library folder. What we can do is we can go ahead and add the 3 libraries that we already copied into the workspace. If you right click on the project, go to Build Path, go to Configure Build Path. We go to the Libraries tab. We have an Add External Jars button. Click on that. And let's go find our workspace on the desktop. And we'll add all 3. So we'll do jcommon, add external jar, JFreeChart, add external jar, JSerialCom. Click OK. We now see that down here we have a referenced libraries folder, and they're listed here. Alright, we can now actually make the program. If you right click on the project, go to New, Class. We need to give the class a name. I'm going to call it Sensor Graph. We want to check the box down here for public static void main, because at least one class in your Java program needs to have a main method or function. Click Finish, and we have our empty class. So let's get right to it. we want to create a window. In Java, that's called a JFrame. Let me zoom in to make it easier for you to see. Alright, so these red squiggly lines indicate that we have an error, and we need to import that particular class. Alright, let's configure the window. We obviously want to give it a title. There's a method called setTitle, and let's call it, I guess, the same thing, sensor graph GUI. We can set the window size. In case it's not obvious, I'm using my arrow keys to go up and down the list. Press enter. We'll give it a width of, I don't know, let's try 600, and a height of maybe 400. We need to set a layout. In my earlier Arduino video, I did not set a layout because there was only one item, a slider. But in this slightly more useful GUI, we have multiple items and you need to organize them. And that is done with a layout manager. So if we call window.setLayout, I'm going to use a layout manager called border layout. So new border layout. And again, we'll have to hover over that and then click on import border layout. I'll explain why we're using border layout. So with border layout, it splits up the window into regions. You have a upper region, a lower region, a left region, a right region, and a center region, which is how many programs are laid out. You might have like a toolbar at the top, might have a status bar down below, maybe some navigation on the left, and then kind of the main thing you're working with in the middle. So it's a very, very common layout manager. Another thing we need to do is tell the window what to do when you click on the close button. There's a method called setDefaultCloseOperation. We need to give it a argument, and you call JFrame.ExitOnClose. What that means is, you know how like on your window you have the close, maximize, minimize icons? Well, if you don't put this line in, when they click on the close button, the graphical part, the GUI, will go away, but the program will still be running. What we're doing now is we're telling it, when they click that close button, close the entire program. That's what you usually want. And finally, something you might easily forget if you haven't done a lot of GUI programming before, is you need to tell the window to show itself. There's a method called setVisible. Come on, setVisible. Make that true. Alright, if we run the program now, let's zoom out. Click the play button up here. We want to always save, and click OK. And so we have this really boring window. But you can see our title is right here. We have a size of 600 by 400. And if we click on the X button, the entire program goes away. Alright. So let's populate the window. At the very top of the window, let's have a drop-down box where the user can pick which serial port to connect to, and then a connect button to actually establish the connection. In Java, they call the drop-down box a J combo box. So we'll create one of those. And it can contain really any type of object. We're going to have it contain in strings, like com1, com2, com3. Let's call it a port list. Alright, and again we have to import JCombo box, so you hover over it, click import. Let's create the button. The string right here is the default text on the button. Again, we have to import JButton. And with a layout manager like we're using border layout, each region can only have one object. And what you can do is you can take multiple objects and put them on a panel, or as they call it, a J panel, as everything starts with J if you haven't noticed. So we'll create a J panel. Let's call it top panel. Yet again, we have to import JPanel. And we can go ahead and place our combo box and button onto the panel. So you do top panel dot add. And first we'll add the drop-down box, port list. Then we'll add the connect button. Alright, finally we can take that panel and put it in the top region of our window. And the border layout manager calls that region north. So as you might expect, the top region is north, the right region is east, and then you have south, west, and center. So we do window.add. Window.add. We're going to take our top panel. We're going to put it in the north region. So you do border layout dot north. Alright, let's take a look at what we get. So we'll go back to the play button. Here we can see we have our window. And we have our connect button, which doesn't do anything, and we have a drop-down box with nothing in it. So let's fix that. First, we will populate the drop-down box with the list of serial ports. There's a method in our serial port library that will give us an array of serial ports. So we have a serial port array. Call that port names. There's a method called serial port.get com ports. We now need to loop over that array and add each element to the drop-down box. So how you add an item to the drop-down box, or JCombo box as they call it. So that variable is port list, and there's a method called add item. And because our combo box contains strings, we need to give it a string. And because we're looping through the array, we have an element in port names at index I. And there's a bunch of different methods. We want to use get system port name. Don't use descriptive port name, it's not what you might think it is. System port name is like COM1, COM2, it's the one you're probably thinking of. Alright now. So now we have the drop-down list, and it has COM1 and COM3, and but still the connect button does not do anything, and we don't have our graph. So we'll close out of this. We're gonna work on the connect button at the end, so for now let's create the line graph. We store all of the sensor values in what is called an XY series, and that's basically a list of, as you might expect, X and Y coordinates. When you create the object, you need to give it a title. Because I'm using a light sensor, I'm going to give it a title of light sensor readings. And again, we need to import that class. We're only storing one particular, or we're only reading and storing from one particular sensor. So you might think that this is all we really need, but we actually need to put that in a collection, because the graph can do multiple line graphs, layered on top of each other, and it expects a collection, not just one series. So we have an XY series collection. I'm going to call it dataset. And we can pass in an XY series. Again, we need to import that XY series collection. If you had multiple series, you could call, I believe there's an add method. Add series. So if you wanted to maybe graph a light sensor, and then maybe a barometer, and maybe an accelerometer reading, and look at them all in the same graph, you would create multiple series, and then you would add them all to your one series collection. But again, we only have one light sensor in this particular project. Alright, we now can create the chart. The object is a JFreeChart. I'm going to call it chart. And there is a class called Chart Factory, which is what you use to create all of the charts. Now if we look here, there is a whole wide variety of area charts, bar charts, box charts, just a whole bunch. You'll want to look into them because it's actually a really neat, powerful library. In this particular case, we're going to create an XY line chart. So if we scroll down to here, there's two possibilities. We want the shorter one. So again, we're going to need to import JFreeChart. And it's asking for a bunch of things. Let's put that semicolon in before I forget. Graph title. How about we call it light sensor readings. X-axis label is going to be time, and the units are seconds because we have the Arduino send one piece of, or one reading per second. the y-axis label will be the value. In this case, I'm going to just put ADC reading. And then dataset is what I call the XY series collection, which matches up with the default. Alright, finally we need to put that chart on screen so you can see it. You do that with a chart panel. So we're going to do window.add. We need to create a chart panel object, and we're going to pass that our chart so that it knows what to create a chart panel of. We want to put this in the middle of the screen, so that's border layout.center. Yet again, we have to import the chart panel class. Alright, let's take a look at what we have so far. Okay, so now we have something that looks a little more complete. It's not yet functional, but it has all the pieces. We have the chart title, we have the axes labels, we have the name of our XY series down here, which is corresponding to this line, light sensor readings. And by default, it'll have a range of 0 to 1 and 0 to 1. It will auto range by default. You can also set it to a specific range if you like. But anyway, so now we need to actually make it work. Our connect button still does nothing. Let's fix that. Okay. Let's make the connect button work. So what I'm going to do is I'm going to have another thread running in parallel, and that thread is going to actually listen to the serial port, and when it gets data, it is going to insert that into the graph, or the chart, whatever you want to call it. So what we need to do is we need to connect some code to our connect button. The way you do that is with an action listener. So our connect button is called connect button, surprise, surprise. There's a method called add action listener, and it takes an action listener object. So we create a anonymous object, if you want to call it that, and then we need to define it. So we have to have the pair of braces there. We need to import this class. And finally, we need to define a method, which is action performed. Let's clean this up a little bit, make it a little more compact. You don't have to do that, but I like to keep it compact. Alright, what we need to do now is figure out if we're connected or not connected. And I'm going to do that by looking at the text on the connect button. Because when we connect, I'm going to change that text to disconnect. So that's a really easy way to keep track. So what we're going to do is we're going to do an if connect button get text and check if that is equal to the word connect. If it is, we need to attempt to connect to the serial port. Otherwise, the text is probably equal to disconnect, and we need to disconnect from the serial port. Alright. We should create we need to create an object that represents the serial port we're going to connect to. before our main method, let's create an object. It needs to be static because we don't have a sensor graph object. We're doing everything in main to keep it simple and short, so we need to have it be a static object. So static, the type is serial port. I'm going to call it chosen port. So back down here in our event handler, our action listener, if you want to call it that, we go chosen port. There's a method in the serial port class called getComPort, and it expects a string. And that string is going to be the text in our drop-down box, which happens to be port list. We need to get the selected item, and we need to convert that into a string. So what that is doing, let me see if it'll run real quick. What we're doing is when this connect button is clicked, we want to get this text. We want to get, in this particular case, COM1. Or now we want to get COM3. So that is what we're doing. Our drop-down box, we're getting the item that is chosen, and we're getting it in the form of a string. We're giving that to the getComPort method, and it will then give us the correct serial port object. Alright. We now need to configure that serial port. We do chosen port, set com port timeouts. The first argument is a timeout value, or a timeout setting. We use serial port T. Alright, so we have a bunch of timeout options. We have non-blocking, read blocking, and so on. The one we want to use is timeout scanner. A scanner object is a really easy way to read text from a stream, in this case a serial port. And that's how we're going to use it. So timeout scanner. And the next two values are the actual timeout times. We're going to set them to 0, which is infinity. In other words, if we ask for a string and it isn't there yet, just keep waiting. We now need to call the openPort method. And that will return a boolean. It will return true or false, depending on whether or not it was able to open the port. And we want to actually check, because if we were not able to open the port, we want to let the user try again with perhaps a different port number. So let's put this in an if block. So if that returns true, if we were able to successfully open the port, we want to do two things. First, we want to change the text on our connect button to disconnect. So set text disconnect. And the other thing we need to do is our drop-down box, port lists, we want to make it disabled. We do that by calling set enabled to make that false. And that's because when you're connected to the port, there is really no reason for why you want to change COM1, COM2. You're connected to it. You can't change it while you're connected. Alright, so now we want to create a thread which will listen to the serial port, and when it gets data, it will update the graph. In Java, there's a class called thread. And in that class, we need to define a method called run. The run method is what actually, well, as you would expect, it's the code that gets run when you start that thread. Alright. In that thread we're going to create a scanner. A scanner is an object that is a very convenient way to read text. So we're going to create a scanner. I could call it a scanner, I guess. And we need to connect it to something. Normally you would connect it to system.in, which is basically your keyboard, your how you would communicate at a console, at a terminal. But we want to connect to the serial port. So we're going to do chosen port. There's a method called get input stream. Okay. We now need to check, or we need to wait for lines of text to come in. And actually we need to import the scanner class. Alright, we need to wait for lines of text. There's a method in scanner called hasNextLine. And that will block until another line is available. And then it will return true. What we need to do is we need to get that line of text. I'm going to store it in a string called line. Alright, so we have the line of text. We want to convert it into a number. Store it in an integer. We call it number. We need to convert that string into a number, and there's a method in the integer class called parseInt. So integer.parseInt, and you give it your string, which in this case would be line. So we got a line of text from the serial port. We have that in the form of a string. We want to convert it into an integer. So we convert it and store it in an integer. Finally, we want to put that in our series, which is what our graph listens to and then shows. See, series.add. We have x and y. Okay, so y is the number. It's the ADC reading. X, I'm going to have it be an incrementing number. So let's actually create an integer called x. We're going to start x at a value of 0. And let's increment it every time we read a line of text. That way the first reading we get from the Arduino will be x equals 0. The next one will be x equals 1, x equals 2, 3, and so on. So it'll automatically sweep across our graph. In theory, this while loop will never end because it will block until we have more text. However, if you, for example, unplug your Arduino, it will usually detect that and it will return false, which means our loop will end. And the correct thing to do would be to close that scanner. You don't technically have to. When you close your Java program, it will close it for you, but good coding style kind of demands that you do that. Or, well, it doesn't demand, but it's a good thing to do. A very, very common mistake is to create a thread and then forget to actually run it. So we need to call the start method. We do thread.start. Now we have that thread running. Now it's going to create a scanner and it's going to listen for lines of text. And it will do that in a separate thread, so that way your graphical interface will still be responsive while it is listening for text. We're very close to the end, just hang in there. Alright, so finally we need to handle disconnecting from the serial port. Call chosen port dot close port. That will close the serial port. We want to re-enable that drop-down list because we disabled it earlier. Set enabled, make it true. And finally, we want to change the text on the connect button back to connect. Alright. Let's see what we have. Click the play button. believe my Arduino is COM3. Let's find out. Alright, so here we have it working. You can see that it changed the connect button to disconnect, and we are no longer able to click here, which is good because that wouldn't make sense. We see that the graph is updating live once per second, and these are the X values. Remember, it started at 0 and then 1, 2, 3, keeps on incrementing. The ADC reading is the number we get from the Arduino. So again, with just ambient lighting in the room, see if I can get this in frame. With ambient lighting in the room, we're looking at roughly 450. If I cover the sensor, it shoots up. Take my finger back off. Oh, I think I just wiggled it free. Let me, there we go. So now it's back toward 450. If I shine a bright light on it, my flashlight, you can see that it drops down to about 100. Now, intuitively you would think brighter light you would want a higher number, so let's fix that real quick. If we click disconnect, we again see that our connect button is now really able to connect, and we can choose this again. But anyway, let's fix this. Close our window. So before, we were just putting our number into the series. What we want to do is 1023 minus the number. And that's because on the Arduino, the ADC will give you a value from 0 to 1023. So if we take 1023 and subtract the value we got, we're basically changing the direction. And one thing I probably should have done that I forgot is we want to put this in a try-catch block. And the reason for that is if for some reason we get a line of text and it's corrupt, it isn't just a number, maybe there's some jumbled up letters or something, we're going to get an exception, and that could cause the program to crash. So what we're going to do, we're going to put a try-catch block. Try, and then let's indent these. And we do catch. Exception E. Now in this case, I don't really care to try and recover from it because it's only one sample, and we have one every second coming in. So I'm not going to try and recover. I'm not going to display an error message. What will happen is if we get an exception, it's going to do nothing. It will just let this loop try again, and it will act as if nothing ever happened, which is kind of what you want in this case. If you're doing something more mission critical, you obviously want to display an error message. Anyway, let's run it again. Alright, so we have our window. Let's go to COM3, connect. And here we have our readings. Now, we can see again, we're roughly in the middle. We're at about 550. If I cover it up, now it drops down, which is kind of what you would expect for darker. That's, you'd think a smaller number. So we have around 200. And if I take a bright light, now it shoots up toward about 900. At the beginning of this video, you saw the result, the end result, which was the 20-hour experiment with the Arduino sitting in my windowsill, and then the resulting graph that came after that. I'll go ahead and show it again just for completeness. So we can see that we have about 20 hours of recorded data. Alright, so we see that it did work just fine. I did notice, however, there were a couple bugs that should be fixed. One of them was if you were to have clicked the disconnect button and then connect again, it wouldn't work as you would expect. And what I needed to do was, instead of defining the X variable inside the thread, I'm going to cut that and put it all the way at the beginning outside of main. as a static variable. That way X will always save its state. So when you click disconnect, if you reconnect, it will be at the previous value. So for example, if you had it catch 10 readings, click disconnect. If you connect again, it will then continue on from 11. And that's kind of how you usually want it. The other issue was I found that if I let the computer sit for a very long time, it would sometimes not update, not redraw the window. And I believe that's because I should have done window.repaint. So window. And what that'll do is it will tell the entire window to redraw itself, and it will do that after every piece of data that it gets from the microcontroller. And that should fix the problem. And kind of an optional thing is when you disconnect, you could have it reset the value of X and erase the contents in your graph. So right now it does not do that. Let me show you how that works. Alright, so we have the graph. You can see there's the Arduino, and it will respond accordingly. If I click disconnect, now if I reconnect, it will pick up where it left off. You can see it's again working the way it should. If you would prefer that when you click disconnect, the data is erased and you start back over from 0, what you can do is in the disconnect area, go series.clear. That will empty the contents out of the graph, and then you can reset X to 0. So let's try it out again. Okay, so we have it. It's graphing data. No problem. Now if I click disconnect, you see the graph has gone away. If we reconnect, it will start back at 0. And there you have it. So that's kind of a user preference depending on how you want to do it. Another neat thing that I forgot to point out was this graph is actually interactive. So you can right click on it. You can save it as an image if you want, as a PNG. You can also zoom in. So if you click and drag with your left mouse button, it will show you that region. If you then click and drag from right to left, it will zoom you back out. And there's other things you can do. You can print, you can zoom in, zoom out, or you can auto range. So it's a pretty neat graph library. I really like it. It's rather easy to use and really quite powerful. So finally, we have this neat little graphical user interface, but not everyone is going to have Eclipse, or not everyone's going to want to run Eclipse every time they want to run their program. So what we can do is we can export the entire program into a jar file. A jar file is a Java archive, which is the equivalent of an exe. And it's really easy to do that. So if you go over here, if you right click on your project, if you go down to export, go to Java, runnable jar file. Not jar file, but runnable jar file. Click next. You need to pick the project you just worked on again, so pick sensor graph if you named it that. Let's save our jar file on the desktop. I'm going to call it sensor graph. Click Save. Now you want to click over here where it says Package Required Libraries into Generated Jar. Then you click Finish, and it will be on the desktop. So we can close out of Eclipse. You see here on the desktop we have a .jar file, and that is the one you can just double click on. And just like that, you have your program. You don't need Eclipse open every time. We can connect to it, make sure it still works. And it's working just fine. Alright, and the neat thing is with a jar file, that's the only thing you really need other than Java. So if you want to give your program to a friend, they probably have Java installed. If they don't, they can install Java. If they're not going to program in Java, they do not need the JDK. They do not need the Java Development Kit. All they need is the JRE, the Java Runtime Environment. So if they bring up the web browser, type in JRE, download it, install it, they can do what we just did. They can take your jar file, double click on it, and a second or two later, you're ready to go. Alright, so I hope you enjoyed this video. I know it was kind of long, but I wanted to explain everything so that you actually know what you're doing and not just copying code. If you have any questions or comments, please leave them down below. I hope you enjoyed the video. So if you didn't, please also tell me why you didn't and how I could improve. If you could give the video a thumbs up if you liked it, I'd appreciate that. Have fun.